You're holding something small. Maybe it's your phone, smooth, light, easy to forget. Inside it, tiny circuits move electricity in careful patterns, signals, information, a world of complexity, all packed into something you can lift with one hand. Now imagine crushing it, not breaking it, not bending it, crushing it so completely that every atom is forced closer together. Electrons pushed into protons. Space itself squeezed out. It would not look like a phone anymore. It would not even look like matter. It would become something else, something dense, something extreme, something that barely belongs to the world you know. Now lift your eyes from your hand to the sky. At night, the stars seem calm, distant points of light, quiet, permanent. But they are not calm. They are not permanent. Every star you see is a battle between gravity pulling inward and nuclear fire pushing outward. A balance that holds for millions, sometimes billions of years, until it doesn't, because eventually, every star runs out of fuel, and when that happens, gravity wins. The star collapses, fast. In some cases, the outer layers explode outward in a supernova, an explosion so bright it can outshine entire galaxies for a short time. For a moment, something dies and becomes more visible than everything around it. But the core does not escape. It falls inward, and inward, and inward. Atoms break. Electrons and protons merge into neutrons. Matter becomes something denser than anything you have ever touched. What remains is no longer a star in the way you understand it. It is a dead star, a neutron star, and this is where things stop making sense, because what's left behind is about the size of a city, not a country, not a planet, a city, roughly 20 kilometers across, small enough that you could drive around it in a few hours, if driving were possible. But it's not, because that tiny object weighs more than the sun. Let that sit for a moment. Everything you have ever known, the oceans, the mountains, every person who has ever lived combined, they are nothing compared to the sun. And now, imagine something no bigger than a city, holding even more mass. It should not exist, but it does. And now, we take one more step. Because somewhere in the strange mathematics of physics, in the deep equations that describe gravity and time, there is an idea that feels like it shouldn't be allowed. If black holes are objects that swallow everything, what if there are objects that do the opposite? Objects that cannot be entered, objects that only give, objects that push matter and light outward, endlessly. A reverse of a black hole, a white hole. You are about to step into a place where time may not behave the way you expect, where cause and effect might not move in the direction you feel. Because if white holes exist, then somewhere in this universe, something might be flowing backward. And that changes everything. You are standing on solid ground. It feels stable, reliable, permanent. Your feet press against the earth, and the earth presses back. Gravity holds you here with quiet strength. But gravity is not just a force that keeps you from floating away. It is the architect of the universe. It builds stars. It destroys them. And sometimes it creates things that stretch the limits of reality itself. Let's go back to that dead star, a neutron star. Imagine taking Mount Everest, the tallest mountain on Earth, and compressing it into a cube the size of a sugar cube. That is the kind of density we are talking about. A single teaspoon of neutron star material would weigh around 1 billion tons on Earth. 1 billion. That is more than all the cars on Earth combined. In your hand, a spoonful. Impossible. And yet, real. Now picture this. You are approaching a neutron star. From far away, it doesn't look like much. just a small sphere in space. But as you get closer, something strange happens. Light bends, not metaphorically, physically. Gravity is so strong that it warps space itself, curving the path of light around the star. You could see the back of the object while still looking at the front. Reality starts to distort. And then there is time. Near a neutron star, time slows down. Not in a poetic sense, literally. If you stood close to it, if that were somehow possible, time for you would pass more slowly than for someone far away. Minutes for you could be hours for someone else. Time is not fixed. It stretches. It bends. Now take one more step. If the collapsing star is massive enough, gravity doesn't stop at a neutron star. It keeps going. The core collapses further, beyond neutron degeneracy pressure, beyond anything that can resist it. And a black hole is born. A region of space where gravity is so strong that not even light can escape. There is a boundary, the event horizon. Cross it, and nothing comes back. Not matter, not light, not information. From the outside, a black hole is simple. It has mass, spin, and charge. That's it. Everything else, erased. But what happens inside? Physics does not have a complete answer. The equations of general relativity predict a singularity, a point of infinite density where the known laws of physics break down. A place where space and time as we understand them no longer exist. Infinite. It's a word we use casually. But here, it becomes something else, something dangerous. Now, here's where things get strange, because the equations that describe black holes also allow for a mirror image, a mathematical possibility, a white hole. If a black hole is a region you can enter but never leave, a white hole is a region you can never enter, but things can come out endlessly. Matter, light, energy, expelled outward, and you cannot go in, ever. It is the reverse of everything you expect. And it gets stranger. A white hole would violate the normal flow of time as you experience it. Because in our everyday world, causes come before effects. You drop a glass, then it shatters. But in the equations that describe white holes, it's as if the shattering comes first, and the drop never happens. Time, in a sense, is reversed. Not for you, but for the system. Now pause, because this is the moment where the universe becomes deeply uncomfortable. If white holes exist, they might be connected to black holes. Some theories suggest that what falls into a black hole does not disappear. Instead, it could emerge somewhere else, through a white hole, a tunnel through space-time, a bridge. This idea is often called a wormhole. But there is a problem, a big one. No white hole has ever been observed, not once. Every object we have seen behaves like matter moving forward in time. Stars form, stars die, black holes grow, but nothing has ever been seen spontaneously ejecting matter in the way a white hole would. No confirmed evidence, just mathematics. And yet, the math works. And that is hard to ignore. Now here's the gut punch. The observable universe contains over 2 trillion galaxies. Each galaxy contains billions or even trillions of stars. And somewhere among all of that, we have found countless black holes. But not a single white hole, not one. In a universe this large, silence means something. It suggests either they are extremely rare, or they do not exist at all, or worse, they existed once, and we missed them. Because some theories suggest white holes might be short-lived. They could appear suddenly, release enormous energy, and vanish. A flash, gone. You wouldn't see it coming, and you wouldn't know where to look. Now imagine this. You are floating in deep space, no stars nearby, just darkness. And suddenly, light erupts from a single point. Matter explodes outward. Radiation floods the void, a white hole. For a moment, something appears that should not exist. And then it's gone. No warning, no trace. Just a question left behind. If something can exist that only gives, never takes, what does that say about the direction of time itself? And more importantly, what if we're looking at it the wrong way? You are here, on a small planet orbiting an average star, in a galaxy that is just one among trillions. Everything you have ever known exists within a thin layer of air wrapped around a sphere of rock. And yet, from here, you are trying to understand objects that break reality. Black holes, white holes, the birth and death of stars. You are asking questions that the universe does not have to answer. And still, you ask, because something in you refuses to accept that the universe is beyond understanding. Even when it clearly is, white holes may not exist. That is the honest truth. There is no observation, no direct evidence, only equations that suggest they could. But those equations come from our best understanding of gravity, Einstein's general relativity, a theory that has passed every test we have thrown at it. So when it whispers that white holes are possible, we listen, carefully, because sometimes the universe reveals itself in mathematics long before it reveals itself in reality. But there is another possibility, a quieter one. What if white holes are not separate objects? What if they are part of a larger process we don't yet fully understand? Some modern theories suggest that black holes might not end in singularities at all. Instead, they could transition into something else over immense timescales. From the outside, a black hole looks eternal, but deep inside, beyond the event horizon, something could be changing. Slowly, unimaginably slowly, until one day, it becomes something that releases what it once trapped, not as a sudden explosion, but as a transformation, a reversal, not of time itself, but of the story. You cannot see it happen. You may never know it happened, because the timescales involved are beyond human comprehension. Trillions of years, long after every star you can see has burned out, long after galaxies fade, the universe grows dark, cold, quiet. And in that silence, black holes may begin to change. If that is true, then white holes are not something you can find easily. They are something you would only see at the end of everything. A final act, a release. Now come back. Back to your hand. Back to the small, familiar world you started in. You are made of atoms that were forged in stars that died long before the Earth existed. Explosions scattered those elements across space. Gravity gathered them again, built planets, built oceans, built you. In a way, you are already part of this cycle. Creation, collapse, transformation. The universe does not move in straight lines. It loops, it recycles, it reshapes itself. And somewhere within that process, there may be things we cannot yet see. White holes might never be found, or one day, we might detect a signal, something that doesn't fit, something that shouldn't be there. A burst, a release, a moment where the universe behaves differently. And when that happens, it will not feel loud or dramatic. It will feel quiet, because the most profound changes in the universe often are. They do not announce themselves. They simply happen, and you're left to notice, or not. So you look up at the night sky again, the same stars, the same darkness, But now, something has changed, because you know that hidden behind that calm surface are objects so dense they bend time, regions where light cannot escape, and maybe, just maybe, places where the universe gives something back. Not everything is lost, not forever, and in a universe this vast, this strange, this unfinished, there may still be doors that only open one way, and others that only open out.